Class. Today we're going to be talking about pointers, but before we actually get into pointers, we want to talk about this ampersand sign over here, which is the address of operator. So what does this address of operator does? What it does, it returns the address of the object. So for example, over here, we have an integer called a, and it has a value of 10. So when we print this ampersand a thing over here, what it does is because it returns the address of the object. So over here, what we will get is this hexadecimal thing, which is the memory location of where a is being stored. So if we take a look at the memory diagram down here, what actually happens when we call this line of code over here is that the compiler cleans up two spaces in the memory, and then it uses that memory to store the value of these two integers over here, or any variable that is being defined. And then these memory locations also have these numbers, which is the memory location of this specific memory down here. So if we use the ampersand, we can then access this number over here, and it tells us where this variable is being physically stored inside the memory. So when we talk about pointers, pointer is a type of object whose value is the address of the object that is being pointed to. So, for example, if we have a pointer 1 that's pointing towards a variable called a, for example, then the value of the pointer 1 would be the memory location of variable a. So, how do we do that in code? So, to declare a pointer, we add this star sign in front of the name of the pointer, and then we make the value equal to the memory location of the variable that you're trying to point to. And we use this ampersand to achieve that, and for this case, we have pointer 1 pointing to an integer variable a. Notice that we have this type over here in front of this pointer when we declare it. So that this means that this pointer is always pointing towards a variable that is integer type. And this cannot be changed. So during runtime, just like any other C++ object, when we define that it is an integer pointer, we cannot change it. We can change the location where the pointer is pointing towards, so we can have the same pointer point towards another location that stores another integer, but we cannot have the same pointer that is defined to be a pointer pointing towards an integer, point towards something like a character, for example. So another way to define a pointer is that we just define that pointer 2 is a pointer type using the star sign, and then using this ampersand, we obtain the memory location of variable b, and we assign it to a value of pointer 2. So what goes down here in the memory diagram is that the compiler, because these are also objects, so the compiler also gives it a space inside the memory. But instead of having a value over here, the value of the pointer is the memory location of which the object is being pointed to. So for example, in pointer 1 it is pointing towards object a, so the value for pointer 1 is going to be the memory location of the variable a over here, and same for pointer b because pointer 2 is pointing towards b, so the value of pointer 2 holds the memory location of variable b over here. So now we have a pointer that is storing the memory location of an object. What can we do with it? So with this dereference operator, which is the star sign, we can then follow the pointer towards the location of where the pointer is pointing towards, and then obtain that value. So we define an integer a and a b. We give it a value 1 and 2. We set pointers pointing towards a, pointer 2 towards b. What we do in these first two lines is that we print out the memory location of variable a, and also the actual value of a, memory location of b, and the actual value of b over here. So over here, we'll also print out pointer 1, the value of pointer 1, and then we dereference it. Over here, because pointer 1 is pointed towards variable a, so the value that pointer 1 holds should be the memory location of variable a. And then if we dereference it, because the dereference operator follows the pointer to where the pointer is pointing towards, and then obtains the value of the object, this thing should output the value of variable a because pointer 1 is pointed towards variable a. Same case for b, because pointer 2 points towards b. This pointer 2 should hold the memory location of b. And then for here, because when we dereference it, we should get the value of variable b. So as you can see, pointer 1 holds the address of a using an ampersand. We can get the address of a. These are the same, because after we dereference this location, we should get the value that is being held in this location. Same case for b. So the question would be like, why do we want to use pointers? Why do we want to work with objects indirectly? It actually gives a lot of convenience. such as when we're working with passing massive data into like a function. We don't want to copy the entire thing, so we just pass our data through passing in pointers, so we know where the data is being stored, and then that will allow us to achieve copy with a cheaper copy. And then also when we're using dynamic memory, we want to use pointers to keep track of where our dynamic memory is being allocated. Also, in future topics, we'll learn about how arrays are being maintained, and the backbone of arrays are actually pointers, and also like more complicated data structures such as lists and tree, which you will learn about in future topics. They're also being maintained by using pointers. So that is a brief introduction about pointers and how to use them.